That's worth 50 points out of natural empire.
That's not even bad saying the worksheet.
All right.
Yeah,
Let's go ahead and get started.
We
gotta close all of this stuff first.
The ground's outside the camera.
All right. All right. I'm gonna get started here. On Thursday, this Thursday, I'll give you guys a practice exam 2. So next Thursday, we'll have the actual exam 2. Okay. It's about time. I usually do it right around before Thanksgiving. And then, because it will be pretty close to the final exam, but there will be some additional concepts that we'll also add to, get to the final exam. So are there any questions about, the material that we have been talking up to this point? Subroutines, local variables? No, we started to work on local variables. Okay, so that's what we'll do next in this class. All right. Let's go ahead and get started with that stuff. First of all, I'm going to show you where to find all of that material. It's all in Moodle. And I want to show you where we are, at this point, in terms of the notes for this class. So we are now in topic number 7. So we're pretty close to the end. We just have, records to do after subroutines. But subroutines, this is a pretty long topic, because there are quite a few concepts to talk about in this particular topic. If you go to updated subroutine notes, we are now at this point. We are just starting on section 4 at this, in this class. So we'll talk about local variables in this class, and then we'll start to talk about the other, really useful stuff in programming using subroutines. Okay. Are there any questions about where we are, at this point, and the concepts that we have talked about? Okay. Most of the stuff, is actually really related, which means if you have a good understanding of all the material up to this point, the additional concepts, save for maybe reference parameters and also returning values. The last two, section 6 and section 7. The other two, local variables and also by value parameters, are not really that difficult in terms of the concept. So we'll do a lot of traces in class, to illustrate those concepts. All right. So what we are doing now is moving on and start to talk about local variables. Now the term local variables refer to two things, okay? A local variable is first local in terms of scope, which means a local variable is only visible when you are executing inside the subroutine that contains the local variable. From that perspective, it's kind of like having a little stash of Post-its in your office, and nobody else can get your stash. Okay, it has got your name on it. But it's also local in the sense that it doesn't exist until the subroutine starts execution. That's the other part about local variables. So it would be helpful if I just use an example program to illustrate what we are doing up to this point. We have been using global variables. Okay, so with global variables, it's pretty easy to understand. So we have sub1 here, and I'm just going to say x gets a value of 5, and define sub, and define sub, and then we'll define another subroutine here. Define sub, say sub2, and x gets a value of 20. And then in the actual program, we'll say invoke sub1, and then we'll do invoke sub2. And this program more than sufficiently illustrate the concept of global variables, which is what we have been using up to this point. So we'll go ahead and trace this program, which should be pretty boring by now, okay, because we have been talking about subroutines for about a week or so, and this program is fairly easy. There's no recursion. I'm not even invoking a subroutine from another subroutine, okay, so there's nothing tricky about this code. All it is going to do is to illustrate the concept, a concept that we have been talking about since we talk about subroutines, which is the use of global variables. And by the way, the word global variable or the phrase global variable is the other G word that you typically do not want to mention when you're programming in any programming language. Okay? Because global variables they're very handy to use. They're very convenient. Okay? If I want two subroutines to share something, I just use a global variable. But you can also run into all kinds of problems as your program gets bigger and bigger and bigger, longer and more complicated. So we want to avoid the use of global variables altogether if it is possible. Okay? In some cases, it is not possible. But in most cases, you can at least limit how often you have to refer to global variables. Okay, so we'll go ahead and get started with this first, just to illustrate what global variables are about. Okay, we have line number, and then we have a column for x. Now, right here is one aspect of a global variable. You can see that when I allocate a column to remember the line number, I immediately allocate one column for variable x, which means as a global variable, x starts its existence when the program as a whole starts execution. And it doesn't get deallocated until the program gets to the completion, get to post. Okay? In other words, the sense global is not only applicable to where in the program I refer to x, but also applies to the lifespan of x. It exists from the very beginning, and it will keep existing until the end of the entire program's execution. Okay? So this is one aspect of a global variable already. Now, with any variable, we emphasize that we always have to state the precondition. In other words, can we make any assumptions about the value of a variable? In C and C++, and other compiled languages based on C and C++, you always want to make an assumption and say, maybe we don't know anything about x. Okay? Now, there are ways to initialize a global variable in C and C++, but in general, unless you do an initialized global variable, they start with an unknown value. You cannot make any assumptions. And then we'll start the execution of this program. Where do we start?
7.
Line 7, very good. Because line 7 is the first line that is outside of the definition of a subroutine. And on line 7, we are invoking sub1, so by now we should be pretty familiar with the concept of invoking a subroutine. There are two things to do: allocate the leftmost available column, in this case column C, call it return line number, and then remember the number of the line that is immediately following line 7. In this case, it's line 8. That's the first thing we do, and then the second thing you do when you invoke a subroutine is to get into the subroutine. In this case, we are invoking sub1, so we have to continue execution on line 2. Are there any questions at this point? No? Is it boring? I sure hope so. I sure hope it is boring by now. All right, so on line 2, we have another thing that we have to indicate is, hey, x is not defined in subroutine sub1. How can it access x in this case? Well, if it's a global variable, it is visible in the entire program. Okay, so in this case, from line 1 to line 8, I can refer to the global variable x. So there's no problem on line 2 to refer to the global variable x and just say, well, we will just do the usual thing, change it to 5. Then we go to line 3. Once again, we have two things to do. Look up the rightmost active return line number. In this case, it's column C. It tells us that we have to go back to line 8. So we make a note of that. And then we deallocate this particular column just by using the strikeout effect on the word return line number. And now we continue execution on line 8. Okay, no big deal, same boring stuff. Save the reallocate column C, because at this point column C is the leftmost available column. Remember that when we are done, we have to go to post because there are no additional lines after line 8. Then we continue execution on line 2 again. Oops, not line 2. This one is line 5 because we are invoking sub 2. But the most important part is, hey, sub 2 is referring to the same x as sub 1 because it is a global variable. Okay, so in this case, we just say, okay, fine, we'll change x to 20, which is the same x in column B. and then we go to line 6. We basically stop the execution or end the execution of the subroutine. Two things to do: look up the rightmost active return line number, tells us to continue execution at post, and then the second thing we have to do is to deallocate that particular column, and then we continue execution at post. We are all done. Okay. So nothing really surprising here, but I'm re-emphasizing how we use global variables in this particular sample program. Now, we have been using global variables since the very beginning of this class. So, it should not be surprising to you, what we have done here, but the parts that I emphasize is the most important part. Okay? Global variables start its existence from the very beginning, and they can be seen no matter where you are in the algorithm. Okay? Okay, so let's go ahead and change this program a little bit. I'm gonna, I'll just write a new program altogether. Okay, so we'll go ahead and start the new spreadsheet here, and this time we have defined sub. Once again, I'll just call it sub1, but this time I'll have a local x instead of saying just referring to x. I'm now declaring that x is a local variable. So this means unless x is declared as local, at least in pseudocode, it is by default global. Okay, if I just suddenly start to refer to a variable y, okay, with no local y before that, that means y is a global variable. And that's a convention used by most scripting languages. In C, it's not quite like that, but in most scripting languages, if you just start to refer to a name, and it would just basically start existing right away, and it becomes a global variable. Okay, so in this case, I'll just say x gets a value of 5. So same kind of thing as last time, but we'll see that the behavior of this program is different from the other one. Okay, we have sub2 here, and just to make it more confusing, sub2 also has a local variable x. And you know what? We'll do something else too. We'll do something a little bit differently this time. It will invoke sub1, and then when it comes back, it will say x gets a value of 20, and define sub. And then outside of this, we just invoke sub2 and not sub1 directly. Okay, so we'll go ahead and fix the indentation, and we'll see what happens with this program. This program makes use of local variables for one thing, and its behavior is going to be quite different from the other one. All right, so we'll start with the columns that we usually allocate, which is the line number column. And that's it. That's all that we allocate ahead of time, because we do not have a global variable x anymore. If you look at all the references to x on line 3 as well as on line 8, do you think in both cases the containing subroutine has a local x declaration? Yeah. Yep. If that is the case, x is not a global variable anymore. Okay. Yep.
Did you have to say both times in line 2 and 6?
Yes. If I only mention once but not the other time, let's say line 6 does not exist, that means the x on line 8 is a global variable x. Now you can have both. You can have both a global variable and a local variable of exactly the same type. In such case, the local variable takes precedence. It's kind of like having a pile of Post-its. Okay, one pile is the one pile that is in your office is a local variable. The one pile that is outside of your office at the, let's say, the copier is a global variable. So when you have your own local stash of Post-its already, you always refer to your own local stash of Post-its. But when your office doesn't have a stash of Post-its, then you go to the copier area and use the one that is accessible to everybody else. Okay, so we don't have a column for x anymore, not from the beginning of the execution of the program. So the precondition is really simple in this case. There's nothing to say. I do not have any global variables to say anything about. No question marks, nothing. Okay? So that's one main difference between this program and the other one. When we get to line 10, we do all the usual stuff. Okay? We indicate the return line number. In this case, it is post because line 10 is the last line already. And then we continue execution in the subroutine that we're invoking. In this case, it is line 7 because line 6 is a declaration, which means I am only telling you that x is supposed to be a local variable, but there's really nothing to do on line 6.
We don't assign it the local entity. Well, no, because you said that
Well,
if we just see it in a.
But there is one thing to do, but we don't do it on line 6, but there is one additional thing to do. It is done when you invoke the subroutine.
Okay.
Okay?
That's
Is
the annotate that's local.
Yep. That we say, oh, but hold on a second here. We now need a second column for our local variable x. But the allocation of this column for local variable x is still using the same mechanism, which is the leftmost available column. Okay? And because it is just a local variable, it always starts with an unknown value. Okay? This question mark is just as important as the question mark for global variables, if not more. Because local variables, unless it is quote unquote an initialized local variable, it always starts with an unknown value. So in this case, it is unknown to begin with. So this is a little bit of a different thing. I mean, column C was not in use until we get to row 3 of the trace. Are we doing okay so far at this point? Yep.
But you said you're not invoking it until after you've acknowledged. I'm sorry, you're not declaring the variable until after you've acknowledged that you're invoking the subroutine.
The
as
invoke statement
being declared it, right? I want to make sure I have that right.
The invoke statement will do the allocation as well.
It allocates that we have a local x.
Right.
Okay.
Yeah. At least in this class. In cisp300, that process itself will be broken down into some sub-steps. So
Okay.
a part of it is actually done inside the subroutine by the time we get to cisp300. But in this class, we'll just say that we pre-allocate everything when we get to the invoke statement.
Okay.
Okay, so now, by the time we get to line 7, we already have one local variable x. And the most important part is this variable x did not even exist until we invoke sub2. Okay? On line 7, which is right here, we're invoking sub1. Okay? We do exactly the same thing as the other one. We have a return line number. In this case, it does return to line 8, so we have to remember line 8 here. And then we continue execution in sub1 on line 3. But remember, sub1 has its own local variable. So that means we have to allocate another column for the local variable x in sub1, and it also starts with an unknown value like that. Yep.
Why are you giving a different column now and not in the last trace?
Because in the last trace, x was a global variable, and there's only one.
Okay.
But in this case, because x is a local variable, it is local in two senses. It is local in terms of scope, which I'll demonstrate later, but it's also local in terms of lifespan. So x is just like return line number. You allocate one per invocation. So every time you invoke, there's a new column for each local variable. Okay. So now we have two local variable x. So by the time we get to line 3, oh, which one are we going to use now?
Oh. C.
Well, we always use the rule of using the most recent one. So in this case, the most recent one, which is also the rightmost one, is column E. Okay? It is column E that we are modifying with a value of 5. This part is very important because now we have two columns. Column C is labeled X. Column E is also labeled X. The reason why we do not use column C is actually two-folded. One, we are not even in subroutine sub2 at this point. Okay, we are now currently in sub1. But that's not even the most important reason. The other reason is the scope is limiting so that variable X on line 6 inside sub2 is invisible to sub1. So there are multiple reasons why we have to use column E and not column C. Are we doing okay so far?
So unlike an array where you can see either it's organizing or it's starting to,
It's
you
static.
can see all the items stacked. Yeah.
Right.
In this, each level is self-contained.
That is correct. It's on a per invocation basis. So until you invoke a subroutine, let's say you have a let's say you have a subroutine with 20,000 local variables, okay? But if nobody is invoking that subroutine,
You can't see any of them.
well, not only you do not see any of them, it doesn't use up any columns. Okay, so this is strictly on the fly, basis and not pre-allocated. Okay. All right. So now after line 3, we get to line 4. Okay, line 4 has a very typical thing to do. We look up the rightmost return line number, which is line 8. We make a note and say that the next step is to continue execution on line 8. And then we remember the usual stuff. We have to deallocate the column corresponding to the return line number that we just used. Okay, so that part is no surprise. We have done it for many times already. But then, what about this X here? It is also done on a per invocation basis, which means when the invocation is done, we also have to do the same thing here and deallocate column E. Just like that. So both column D and column E are deallocated on line 4 when we are done with subroutine sub 1, when we're done with that invocation. Yep.
And what happens to the 5?
What happened to the 5?
Yeah.
It is, well, that's a very good question, okay? That is a very good question because unlike a stack of paper where you can just kind of rip it and toss it into the trash can, you cannot just rip bits, from the memory location of your computer. So the memory location is still there. In other words, just like in the spreadsheet, column D and column E are still in the spreadsheet after line 4 executes. The difference is, whatever is not your allocation, the content can change without any notice to you. Okay?
Say that again.
In other words, say again? Okay. Okay. So when we are here, when we're on row 9 of the trace, okay, we are continue execution on line 8. There are stuff happening in the background, quote unquote, in the background when you run the computer, when you run the program. So what that means is by line 8, there can be stuff, little gremlins running around and modifying column D and column E to whatever they want. But why should you care? Because it is not a part of your program anymore. Right?
You just had to establish a value, and that's all that you cared about because that's all you were asked to do.
You have to know which part is yours. Okay. So let me finish this, and then I'll use a little highlight, to highlight which portion is guaranteed not to be changed by these gremlins, and then the rest of all the columns can be used by.
Amenable.
Yep. They can be changed in the background. Okay. So on line 8, we have a simple thing, which is to change X to 20. But by now, it's X is column C is the most recent definition of X. So X is now column C, and this one gets a 20, and then we get to line 9, and you probably know what's going to happen here. We just basically have to deallocate both columns after we make a note that we have to continue execution and post. And once we get to post, we're all done. Everything is, there's nothing else to do. Okay. Column A is completely artificial. We have a column A only because we want to trace the program and remember at which point we were where in the program. So column A does not actually exist when you run the program. No, I take it back. Column A does exist, but it has a very special name inside the processor. Okay, so for those of you who want to know what it is, but most of you probably cannot remember, it's called a program counter. Okay, or otherwise known as an IP or instruction pointer. Okay, so program counter or instruction pointer refers to column A, but it's not really a part of the memory of a computer, it is a special register inside the processor. Okay, we'll talk more about that when we get to cisp310. The other columns B, C, D, and E, they correspond to pretty much general, the memory inside the computer. So if I want to show you the, in-use time of those columns, this is kind of what I would use to show that they're actually in use. It is debatable whether on row 10, I should really highlight it in yellow, because I really should not, because by that time it is not allocated anymore. So I have to, well, if I undo, it's going to undo all of the blocks, which may be faster, but I can also take out just the background on certain cells. So technically speaking, this is what I should draw, because by the end, when we are done with line 4 and line 9, those columns are no longer in use. Yep.
Wouldn't those be different colors to show that they're not stacked though? Would that be a
Funny thing, you should use the term stacked, because in cisp310, that's how we refer to these columns. It is a part of what we call a stack.
Oh, it is?
Yes.
Okay.
And that's why they're using. That's why I'm using the same color,
Sure.
Because they're actually inside the computer. It doesn't make any distinction of which part of the columns or which columns belong to whom. We'll talk about that in cisp310. But in this class, they are kind of different because they belong to two different invocations of two different subroutines. Okay, but the main point I want to make is, outside of this boundary, in other words, when we are on row 3 of the execution of the program, you can have a whole bunch of gremlins, making use of columns, D, E, F, G, and H. They're just running amok and messing around, and all of those columns can be changed, without without you knowing it. Okay, it can all be changed. But why do you care? Are you actually using columns D, E, F, G, and H at this time? No. So you should not even notice the changes of those columns. Okay. Now, by the time we get to row 7 of the trace, you are guaranteed that the gremlins cannot make any changes to these 4 columns. It is guaranteed. Okay, because they are now yours. But all of the other columns, they can still be changed in the background. In other words, whatever is not allocated to the execution of your program can be changed and modified.
It's space available for something else to do something else.
Yes, basically that's the best way to to understand it.
You're showing us what space, or if you look at it as in the memory concept,
Right.
this is the amount of memory we're using.
Right.
There's the X amount left, or a large abundance left. It can be manipulating whatever data we've just processed in any different way. We just done what we've been asked to do with our 1 or 2 simple.
Right. In other words, we are moving a bookmark. Okay, we're moving a bookmark that marks the line. Which part is mine and which part is not. Yep. Go ahead.
I just want to make sure I'm understanding the local versus global variable part of how we're working through this. What we're going to say though is that X at C3, once E5 has been invoked, doesn't know or care what's in E7, right? And when we get back to C9, it doesn't know or care what was in X prior to that.
Because that's sub 2. Now you're in
Right,
sub 1.
because
It's an X that belongs to a different invocation, and
Right.
by this time that invocation has concluded already as well.
Right.
Yep.
Okay.
Go ahead.
So, will there be an instance where we will be asked, if we were to trace this, what is the value of X?
Well, there will be cases exactly like this that you have to trace.
There's 2 values for X.
Right, you have to know which one you have to modify and how you're going to modify it. Okay, now let me give you an analogy that might help you remember all this stuff. Okay, so let's say that have I talked about the U-Haul truck rental
Yes.
analogy? Okay, So that's a concept of invocation. Okay, so we can now extend that example a little bit. Okay, so let's say when I rented the U-Haul truck, I set the radio stations to my preferences. Okay, and when I sublet the truck to somebody else, okay, let's say you may not like my radio station, so you might want to change it, right? But when you change the radio stations, it is changing it in a irreversible way. In other words, by themselves, the radio stations or the settings of the radio stations on the U-Haul truck they are global variables. Okay, station number 1, has a particular frequency. So I can set it to a certain point, but when I sublet the truck to somebody else, that person can change it to something else. And when the truck is returned to me, it's going to be changed. Okay, so in a sense, it is a global variable. Okay, and in many other ways, it also matches the analogy, because remember, the truck itself exists whether someone is renting it or not, and so are the radio stations on that truck.
Yeah, but until you recognize it's not your preference, that's when you establish the local variable. Your
So now
setting.
here's the concept of local variables. Okay, so in order to fix that problem of somebody messed with my radio station problem, okay, here's a solution. I keep a stack of paper in the truck, and it's just labeled station 1, station 2, station 3, and so on. Okay, and the point is, when the truck is not being rented by anyone, nobody's going to use a single page out of that notebook. I'm the first renter, so I get in the truck, and the first thing I do is I'm writing down the radio stations of whatever is preset already. I write it on a piece of paper, and now I'm going to change all the radio stations to my liking. All right? When I sublet the truck to somebody else, I would ask that person to do exactly the same thing. So you would turn to the next page and not to erase what I have written already on that notebook. You would turn to the next page, and then you will write down all the settings on the radio first, and then you can feel free to change it to whatever you want. Now, when you return the truck to me, right prior to that, you will restore the radio stations according to what you wrote down on the notebook. And then you will flip the page back to the page that I was on before. And then when the truck was returned to me, then I will be looking at the page that I need to be reading, which is the first page.
It's almost like the FM1 and FM2 that they sometimes put in there. You can hit FM and it'll go through a couple channels, and it changes each of the settings according to what's been set in one of those pages, if you will. Yeah. Yep.
Is line 4 like that return basically?
Line 4 is basically turning that page back to the page that I was on.
So
Now,
X is unknown at that point now.
You mean E, column E?
C.
Column C?
Subroutine 1.
That's
the
column
two.
C. Okay, but you're on row 8. Are you referring to row 8 of the trace?
Yeah.
You mean this row here?
No, sorry, 9 then.
Row 9? Okay, before row 9 executes, X on column C has an unknown value because it is a local variable and nobody told me what it is supposed to be. Okay, so it has an unknown value. But because of the assignment statement itself, it gets a value of 20 on line 8. Okay, the other analogy I can also make, in the context of a U-Haul truck is also something simple. Okay, when we're moving, we have a checklist of stuff, the address that we're supposed to drive to, and so on and so forth. Okay, you need to write it down on a piece of paper, right? Okay, in the case of a global variable, means there's one single piece of paper. Okay, I would write down, my checklist, my destination, and so on. But when I sublet the truck to somebody else, it's the same piece of paper. So that person is going to overwrite, quote unquote, that piece of paper. It's probably more closer to a whiteboard in that case. Okay, so whoever that I'm subletting the truck to is going to erase all my stuff and then overwrite it with that person's checklist and the new destination. So when the truck is returned to me, I look at the whiteboard. It's like, that's not what I'm supposed to do. This is not my destination. This is the destination of somebody else.
And that's where you can run into problems in your programming using
Exactly.
global variables.
Yep. Now, when you use the concept of a local variable, it basically means that each invocation or each renter of the truck has a new post-it. Okay, so when I wrote down my stuff on the post-it, I stash it onto the dashboard, right? I stick it to the dashboard. The next renter is not going to remove it. The next renter is going to take another piece of post-it, write down his or her checklist and destination, and put it on top of mine. But that's okay, that's no problem, right? Because now we have a stack of 2 pieces of post-it papers, right? If if that person decides to sublet the truck to yet somebody else, then here comes the 3rd post-it paper that is stacked on top of the whole thing. So each renter has his or her own little workspace, and that person can write down whatever that person wants to do. Now the question now is, what do we do when we return the truck? Yep, we just take that one top post-it out, toss it into the recycle bin, and then return the truck to the person who we rented it from. So to that person, now it is restored back to whatever context that person was on, because hey, it's back to my page now. Yep, go ahead.
If we look at the algorithm on row E,
Okay, so you wanted to show the
X gets the value
algorithm
of
itself.
20.
On row 8?
Yeah.
Yep.
Now what if that had said X gets the value of X plus 1?
Then it would not be defined because we do not know the value of question mark plus 1.
Okay.
So that would not have made much. That would not have made much sense. But the C compiler, unless you turn on certain types of checking, would allow you to do that anyway. So your program would basically seem legit, but it's not going to do anything that's useful because you're adding 1 to an unknown value, which is still unknown. So you cannot really make use of that value after you add 1 to it. And that's one problem that you guys have to watch out for, is the C compiler is not necessarily the smartest thing unless you tell it to be smart and complain a lot. You can make the C compiler complain a lot, but that's optional. Yep, go ahead.
So before you said you could have a local and a global variable that would be the same. If you were doing something to both of those variables in the case where they were the same in the same subroutine, like in the
You
first
cannot.
one?
Okay, it depends on how you're going to do it, but in regular C and C++ programming, if you just refer to X, if you have a local variable X, that takes precedence over the global variable X. So when you refer to X, it's always referring to your local variable
So you
X.
have to specifically declare on the assignment line or whatever that you're
Well, there's a specific way to say that this is my global variable X, if I remember correctly, using the workspace, namespace, excuse me, the namespace method. You can actually refer to the global variable if you want to. But that's typically discouraged. The use of global variable is just generally speaking not a very good idea. Okay. So is that a good example? Are we getting the concepts?
So we would establish for our local X sub 1, local X sub 2, we would give you 2 answers to X. Now, what happens to our our local X value of 5? Now
It's
that
gone.
We just don't care. We've already done what we've
It is
been
no,
asked.
exactly. First of all, by the time we get to here, it is no longer accessible.
Correct.
Because those 2 columns are now deallocated. You can see that at this point, column D and column
And
E
we're
are
not
no
even
longer
using-
yellow.
Yeah, we're not even
which-
using those, so we're not even recalling anything.
Even if you
Line.
could refer to those 2 columns, the value of those 2 columns can now be changed because it does not belong to your program anymore. So it can be anything now. So that's why it doesn't really make a whole lot of sense to say, but what about that X, the other X? It doesn't even exist anymore. Those columns are now reused for
This is
something
where
else.
like an integration would occur, where like another algorithm would say, I want
Right.
to call up column E, or I want to call up column E row 6 or row 7, and it would just quickly use that variable. We're done. We trashed it, but somebody else may be doing something with it at that time. Correct.
Correct.
Okay. All right.
It's basically the same thing as when someone returns a truck to me, remember how that person has to take off the top part of the stack of little post-it
Uh-huh.
paper. it's kind of like having me to ask you, what happened to that little slip of post-it? Well, that person could have trashed it, burned it,
Okay.
You erased it and write something else
I don't
on
know, I
it.
just wrote it down.
I have no access
Yeah.
to that anymore. Okay, it's of no concern to me at that point. Yep.
So the the local variables only useful from within the subroutine. That
Only
is-
within the subroutine and only when you're in the actual subroutine itself.
Right. Yeah.
So if you're referring to, let's say we're referring to local variable x of sub2, if I want to highlight the rows where that particular variable is directly accessible, it's going to be just from here. This is on line 7, and line 7 is inside the subroutine. But when we are on line 3 and 4, the x of sub2 is actually inaccessible. We cannot name it. Because remember, only when you're in the subroutine you can refer to a local variable of that subroutine. So when you're talking about x of sub2, well, line 9 technically cannot access it because by that time we're destroying it. So we only can refer to x of sub2 on line 7 and line 8.
So why not just have a different name
Have
the
a different
variable
name?
something different, yeah. Instead of having all the same.
Because
Variable.
what happens when you have 50,000 subroutines?
Yeah, it's
Oh,
like
you gotta
calling
come up with a
shit.
new name every single time, yeah.
And you cannot remember whether you have used a name before
Right.
already. Because if you do, and the subroutines somehow can end up calling from one to the other one, then you have the other one trashing the variable of an earlier one. If you're not using local variable.
So you can refer to a variable within another subroutine.
Only if it's global.
Okay.
Only if it is global.
Okay.
Yep. So global variables are very handy because it allows any subroutine to communicate with any other subroutine. But that's also its downfall because now you can have any subroutine to mess around with
Yes,
a
it's
variable
also
used by
dangerous,
somebody
yeah.
else. Exactly. It's like in an office environment, everybody can come to your cubicle and start to mess around with your stuff, right? I mean, you better put a lock on it, right? Yeah, yep. Yeah. What happened to my Nerf gun? Somebody used my darts. Yep.
I was just curious if the concept of discouraging global variable use, is that kind of newer? Because I was just curious why they would make it that default, why it would default to global variable if we don't want to make it.
I can only think of one thing. It's basically laziness. Laziness on the part of the people who actually designed the language. Because a lot of programming languages were written or designed by people who are experienced. So they tend to think, oh, we know what we are doing, so it's okay for us to do this. But in general, in practice, it's not a very good idea. Yep.
So going on top of that, are there programming languages where local variables are the default?
No, well, okay, there are programming languages where you have to explicitly declare whether something is local or global. C++ is one of those. So there's no way you can say, oh, okay, I just suddenly start to use a variable. You just cannot do that. You have to say global X or local X. You have to tell the compiler ahead of time that I'm about to use a variable called X, and then you have to say whether it's local or global. And which is this is called a strongly typed language. We are not talking about type C. We only talk about global versus local variables. But C and C++ has a very strict way of looking at it. I mean, there's no way it will allow you to just say, I'm going to use a variable something and default it to one or the other. There's no default, basically. All right. So, well, this program is quite useless, don't you think? By the time we get to post, nothing was done. I mean, yeah, we actually allocated column C and column E at one point, but by the time we get to post, there's no answer, there's no conclusion, there's nothing.
I was going to say we've done something, but we haven't brought it through to the end.
Right.
So
And,
yeah.
and all the columns that we have did something to is no longer a part of the execution of this program by the time we get to post. So there's quote unquote no answer. There's no output, nothing whatsoever in this program. Yep.
What, like you said earlier, this could just be an integration for somebody else.
Correct. Well, this is just a demonstration of the concept of local variables.
Pretty useless.
Useless but useful at the same time. Yes. All right. So let's go back to factorial because that's one program that we'll see over and over again. But each time we look at that program, we'll do it in a slightly different way. Okay. So we'll go ahead and define factorial again, but this time we'll give it a local variable x. Okay. And it has pretty much the same stuff as last time. We'll say when n is equal to 0, then the result, which is a global variable, is going to be 1. Else, we'll do the following. The first thing we do is to save the value of n, which is a global variable. And then we say if x, there's no need to if anymore. We just say n gets n minus 1, invoke factorial. By the time factorial comes back, R should have the factorial of n minus 1 in this case. So the result is going to be result times x, which was the old value of n. And if n define sub, and outside we'll just say we want to try to find the factorial of 3. And then we'll go ahead and invoke factorial, give it line numbers, and start tracing. Does anyone have a particularly strong desire to add indentation to it, or should we trace it like it is without indentation? Just for once.
Seems like a biased question. Whatever you want to do.
Whatever I want to do. Well, I think on one hand, I do want to show you guys what happens when we do not have indentation, because it does make it harder to read. It's not impossible. It's just harder. It's kind of like when you're writing an English paper without the proper spacing. Okay, you can still probably read it. Okay, English is really robust. I mean, even if you miss the periods of every single sentence, you can probably still read it because of the capitalization of the first word of a sentence. Okay, but it's harder. Okay. And it's the same way with pseudocode or any type of actual programming. Without indentation, except in the case of Python, it will actually break the program. You cannot do it without indentation. But with most other programming languages, indentation is optional. It's really for your purpose, much more so than for the compiler or the interpreter's sake. Well, we'll go ahead and do it, at least for a few lines. When it's too much, then we'll actually add the indentation back. It's kind of like a competition of who says okay, I can't breathe anymore. All right. So this time we do need comments because we have conditions to evaluate. We have line number, and can anyone help me identify the global variables? In other words, which names that we use? Which name do we refer to in this program that has no quote unquote local blah 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 ahead of it? N and R. But X is not one of those. Okay, so we'll say N is a global variable, R is a global variable. So we pre-allocate columns for those particular variables in this case. And the precondition basically says we don't know anything about those two global variables because we don't need to. The algorithm will take care of that. Okay, what is the first line that we have to execute? Okay, we start on line 12 because that's the first line outside of the definition of a subroutine. And right away we can see that, well, we can find it, but it's a little bit harder. We actually have to scan the lines almost one by one to find out where is n defined sub. Okay, whereas before using indentation, you can see, oh, okay, we can skip this entire section. Okay, it's a whole lot easier. Okay, so on line 12 we initialize n to 3, and then on line 13 we invoke the subroutine. Two things to do: allocate return line number, and also allocate for my local variable x. X is a local variable, always starts with an unknown value. Return line number in this case is post because we don't have any more lines to execute after line 13. And then we continue execution in the subroutine. Now, it's not like we cannot find that we have to start on line 3. It is harder without the indentation. It's just a little bit harder to spot where's the beginning of the entire subroutine. N equals 0 is false because n has a value of 3 at this point. We get to the else. Well, in this case, it's pretty easy to scan because the then portion only has one single line. So it's easy to scan for the else, and we don't have any nested conditional statements either. Now, if you have nested conditional statements with if then else nested within if then else, then it's a little bit harder because now you have to count, right? But this time, it's pretty easy because we only have one level of conditional statement. So we can say, okay, we can continue execution on line 6. But you can definitely tell there's a difference, okay? It's not, easy anymore. On line 6, we copy the value of n to x. N is our global variable. It is visible from outside the subroutine. It's accessible from inside the subroutine. It has a value of 3. X is my local variable. Now it has a value of 3 because I just made a copy of n. And then we move on to line 7. Line 7 says n gets n minus 1, which is our global variable n. It goes from 3 to 2. And then on line 8, we invoke factorial again. And when we invoke factorial, we do exactly the same two things. This is a recursive call or recursive invocation because we're invoking factorial from inside factorial. But it doesn't change a single thing. Okay? We do exactly the same thing, same boring steps that we have always been performing. Okay? We allocate one column for the return line number, and now we have to allocate an additional column for the local variable x. But it's the same x. It's okay. We use exactly the same steps, okay? Because a local variable x in this case is allocated not on a per subroutine basis, but on a per invocation basis. Okay? So that's why every time we invoke, we have to do exactly the same steps and invoke and allocate for that again. So x has an unknown value to begin with. And then return line number in this case is line 9 because line 9 follows the invocation on line 8. And that's how we allocate the 2 columns. Okay? After we allocate the 2 columns and save where we're supposed to return to, it's time to move on and continue execution. In the subroutine that we're invoking, in this case is factorial, we start execution on line 3 again. Are we still doing okay at this point? So the new concept, yep, go ahead.
How come we don't, if it were still in the same subroutine and x had the value of 3, how come we don't know that x is the target?
Because that's the behavior when you allocate a new column for a local variable, it always starts with an unknown value. This is for the next invocation.
Okay.
Yeah, we are preparing for the next invocation and not the current invocation. All right, so now that we are inside the new invocation on line 3, we'll do the same execution. N equals to 0 is false because it's only 2 at this point. We move on to line 6, the first line, after else. We save the new value of n to x. Now, how do I know I'm supposed to use column H and not column F? Because H is the rightmost one that is active. Yep.
You have a row sheet?
I forgot to bring my row sheet today, so it's all right. We can forget once in a while. So everybody is present. Everybody is present until proven absent, right? Yep.
Okay, so I don't want to throw a wrench in the mix here, but line 6, x gets value of n. X is a local x.
Yes.
N is global n.
Yes.
You can correct me if I'm wrong, or just tell me what I'm trying to get at here. X, global x, or local x gets global n.
There's no global x. X is always local in this
Okay, I'm sorry, I just spoke wrong. Local x gets global n.
Yes.
Can you ever say because of that statement, you now have global x?
No.
Okay.
Because x
Because
is
you have
declared.
you have a global n, and you're giving a local x of that value, that.
No, there's global n, but only local x.
Okay.
X is local because of line 2
Correct,
of the program.
yes, correct. We can never assign the fact that n is global to x. Like it doesn't, you see what I'm saying? Whereas we would normally
Well,
just
where
say
you
x
are
gets
could be
n,
different.
we
Where you
just
are.
make x n, but we're calling it local x and.
Okay, I think I see your
global
point.
n.
Because now the n's changing to 2, it's going to be
I see your point.
different on the next local.
How about this? Would that change anything? Because the right-hand side of an assignment is not necessarily a global variable or a local variable or a constant. It is an expression. Whatever the value
It is,
becomes,
okay,
it
okay.
becomes is just a value. So I can change it to n plus 1, n plus 0, excuse me, n plus 0, which doesn't actually change the value that we want. But now it is not referring to just a global variable anymore.
Okay, I got you. That's
Okay.
exactly what I wanted to hear. Perfect.
Yeah, so sometimes we have to kind of remember, and boil everything down to the simplest, the lowest level, because n is really, even
I
though
would
we
have to
look
say
at it
global
as,
n plus global 0.
right, because even though our
Yeah.
focus is now global versus local, but since it's the right-hand side of an assignment, it is just an expression. All
Okay.
we want is a value
Okay,
out of the
perfect.
expression.
Perfect.
Yeah.
Never mind.
Oh, okay. Those are the best questions. Not in the sense that I don't have the answer, but because
I think I see the answer.
But because as you think about the question, you start to make the connections, and okay, here's the answer. Okay, so on line 6, we are copying the value of n plus 1, n plus 0 in this case, which doesn't change the value of n, to x. At this point, column C has a value of 2. 2 plus 0 is 2. So this x in column H is now getting a value of 2 because we always use the rightmost column corresponding to a local variable's name. Are we doing okay so far? Now that part is really important, always the rightmost. Okay. On line 7, we decrement n by 1, so n goes from 2 to 1. On line 8, we're going to do pretty much the same stuff, with, in fact, it is exactly the same stuff. We just say return line number and then x. And here I'm going to pull a little trick here to make it easier to read this. I'm going to use this little tab here. Now let me just do this again. When I put my mouse cursor all the way over here, do you see how it changes to a double-sided arrow? If you drag it at this point, you can now drag you can split the screen into 2 halves or 2 portions, and they can scroll independently. So I can scroll, they scroll horizontally independently, but vertically they're still locked. Okay.
Do that again real quick.
Sure. Okay, originally it looked like this.
Okay.
And then if I hover I have to move my mouse pointer real slow here until we get to here, which is right between this little left arrow thing and the vertical scroll bar. There's a little bit of a symbol here, and then I can just drag it. And now I can move that bar to somewhere else. Then I can independently view the same spreadsheet in two different portions. Okay, so we have return line number and my local variable x again over here. Return line number is always line 9 because the invocation is on line 8. As a local variable, it always starts with an unknown value. And now we can continue execution. In the subroutine that we're invoking, it just turns out to be the same subroutine again. Okay, on line 3, we compare, it is still false, but this is the last time. And then on line on line 6, we copy the value of n, which is now 1, to my local variable x. So x now has a value of 1. And then on line 7, we decrement the value of n by 1. And this is another thing that I will do, is to split the top. So now we can scroll it, we have 4 quadrants basically at this point, and 2 are locked in terms of horizontal scrolling, and 2 are locked in terms of vertical scrolling. It's pretty handy, just a little bit confusing at times. Okay, so on line 7 we put a 0 into n, and then on line 8 we are invoking factorial again. When we invoke factorial, same thing, we allocate one column for return line number, one column for x. Return line number is 9 because the invocation is on line 8 itself. X starts with an unknown value. Continue execution in the subroutine on line 3. Finally, this time n is 0. So we'll go to line 4 instead, change r from question mark to a single 1, and then we are done with the conditional statement. This is where indentation comes in handy too, because when I'm done with line 4, I need to go to the end if corresponding to this conditional statement. With indentation, I can spot it pretty quickly, but without indentation, now we have to actually scan the lines one by one until we get to line 10 and go like, oh, okay, that's the end of the conditional statement. So we have to continue on to line 11 to finish up this particular invocation. On line 11, there's nothing mysterious. Okay, we have to make a note that we have to continue execution on line 9, and then we have no use of these columns anymore, and we just toss it into the recycle bin. All right. Are there any questions about row 23 of the trace? Nothing surprising. I mean, we allocate something on a per invocation basis. By the end of the invocation, whatever we allocated on a per invocation basis, we have to deallocate. That's basically just closing or deallocating things that we have been using a little bit earlier. But now we are continuing execution on line 9. And line 9 needs to multiply r and x. Now column L is now deallocated. It cannot possibly be my rightmost column with a label x, but j is. J has a value of 1, r has a value of 1, 1 times 1 is 1, so I put that 1 back into column D, continue on to line 11, and then we do pretty much the same thing. Okay, so we basically look at column I and column J this time, and say, okay, we don't need these columns anymore, but remember, we have to continue execution at line 9, and then just indicate that these are now deallocated. And now we are back onto line 9. On line 9, we do exactly the same thing. We look up r and we look up x, we find the product. R is my global variable, has a value of 1. And now we have to look up the value of the other one, and it should be 2. I just want to find it. Column H now has a value of 2. 2 times 1 is 2, and I store that back into column D because that's my R. And then we move on to line 11, and then we do the same thing. Column we have to continue execution on line 9. And then we deallocate column G and column H. Oops, wrong place. Undo. There we go. And now we are continuing execution on line 9. The right-hand side wants to find the product between R and X. This is my X here. Column F has a value of 3. And then this is my R, which has a value of 2. 2 times 3 is 6. We store that back into R. Continue execution at line 11. Now we have to look up the return line number, which is column E. It tells me to continue execution at post. And once we make use of that, we don't need these 2 columns anymore. Deallocate those. And then we are now continuing at post, which means we're done. Okay, there's nothing else to do. And we do have the right value in R because 3 factorial is 6. Now, with all this split screen thing going and also the lack of indentation on the other side, things can look a little bit confusing. But I think that's a good point to understand too, is indentation actually is useful because without the indentation, it was a little bit harder to read. I'm pretty sure most of you can follow the logic anyway and scan for the end of something, but having indentation is easier. Okay. Are there any questions about the trace itself too, which is on the other side? I want to show you not the detail anymore. So I'm gonna undo all the split screen stuff. When you want to undo the split screen stuff, you just drag it all the way back to the top or all the way to the bottom, and then the split screen effect will disappear. But I want to zoom out. Okay. It just stacks up because remember, each level is renting the truck to somebody else, and that person has his or her own little postage for the checklist, items to bring, destination, and stuff like that. Even though it's exactly the same truck in this case, we only have one truck, which is factorial. Okay? And on that truck is a radio. It has two radio stations. It has radio station R and radio station N. Those are global. So it doesn't matter who's driving the truck, you still have those two buttons, on the radio in the truck.
Could you make this available on Moodle, this example?
Well, it's being recorded, so we can, yeah. Let me just double check and make sure I'm not lying. Yeah, there we go. There we go. I think, I can put the document on Moodle, but it's different when you have to do it yourself, just, freeze the frame, in YouTube and actually do the trace yourself. And then at one point you can just go back to here to the solution and then compare your trace with what I have here. Because reading it is one thing, I think reading and doing involve different parts of your mind, so it actually is a different process. So that's why I do not want to kind of upload it, because that way most people would just kind of download it and stare at it, which is a form of studying, but it doesn't really help in terms of understanding the concept. All right. So any questions about local variables? Okay. Yep.
Is any of this going to be on the test next week?
I think I will cover everything up to local variables, but not by value parameters, which are closely related to local variables. But it does add something kind of twisty to it.
Are the by value and the by reference are going to be on the 30% then?
I'm going to put it into the final exam instead. Yeah, I'm teaching a little bit slower this semester compared to all my previous semesters. But that's okay. It's important to get the concept down instead of covering more. Are there any questions about this stuff here, about local variables? No questions about local variables? All right. So we're going to move on. We still have about 10 minutes to go, and then we'll move on to the next concept. It is called a by value parameter. Okay, so this is let me just open up a new document first, and then we'll talk a little bit about the concept first. A by value parameter, okay, if you think about it, a global variable is like a resource available to everybody. Okay, so everybody can go to the copier area and use paper cutter and stuff like that, hole puncher and whatnot, at the copier. A local variable is something that is local to your own office. Okay, it's your own stash of Post-its, it's your own stash of scratch paper. But nobody else, cares about all that stuff, because it's just for you to jot down a phone number that you have to return, but nobody else needs to know it. Okay? A by value parameter is like a little in tray in the analogy of an office. It is a way for somebody to give you some information, okay, so that you can process it. Can anyone imagine or remember anything that might resemble an inbox in the case of the factorial subroutine? Does the factorial subroutine need something in order to do its job?
It needs an input.
It needs an input, and that will be
Whatever number factorial. So
we want exactly the number that we want to find a factorial of. In this case, we use the variable n to represent it. Okay, so that's our in tray. So let's see if we can find a. We'll just go ahead and use a simple example in this case first, and we probably won't have enough time to rewrite factorial to make use of by-value parameters. Yep, go ahead.
Why do you have to write sub 1?
He's just calling it
Well, like
Because it doesn't serve any particular purpose, so I don't have a particular name for it. I guess I can call this.
whatever.
Define sub is actually the command X.
I'll just call it increment, okay? So this time I have by-val, x, and it's going to increment my global variable y by x. So y gets y plus x, and define sub. Y has to start with a particular value first. We'll just make it start with, let's say 14, and then we'll invoke increment, and I'm gonna, finish the program only halfway through, and then by the time we get to the part where it is important, I'll finish it. Okay. So when you look at the syntax of this code, it looks kind of the same as a local variable. In other words, x is like a local variable. It has a local scope, it has a local lifespan, it doesn't exist until increments start to exist. But don't we have the same problem here? Like by the time we get to line 3, x doesn't have a value. Okay? That's exactly the point. Because unlike a local variable, which starts with an unknown value, a by-val parameter starts with a particular value. The question is, who is going to specify that initial value of a by-val parameter? It is the invoke statement. So in the invoke statement, we have to now remember to say, oh, increment is expecting a by-val parameter. It has an int tray. So we better put something into the int tray before we tell that person to start processing. Okay? So we'll say, in this case, we'll say, well, let x starts with a value of 5. And that's how I would use the right arrow to indicate that my by-val parameter x is going to start with a value of 5. And I intentionally flip the direction. It's not a left arrow, it's a right arrow. Okay? Because it is not exactly an assignment statement, so I don't want people to confuse that we have an assignment statement. It is not an assignment statement. It's a way to specify the initial value of a by-val parameter. Okay, so let's go ahead and test it and run it a little bit and see what happens when we run this code. It's really nothing that we haven't seen before. It's just a combination of things and with a little twist. Okay, so we have our usual line number. We have one global variable. Which one do you think it is?
Y.
Y, that's exactly it, because y is not by-val, is not local, so it has to be a global. So we got, oops, y here. And this is my precondition. Y starts with an unknown value. And we start execution on the line, the first line that is outside of the definition of a subroutine. In this case, it's line 5. And then we'll go ahead and say, oh, okay, y gets an initial value of 14. Okay, we can do that. And then we move on to line 6. We invoke a subroutine. By now, the return line number thing is easy. Okay. But now we also have to allocate for x. Okay. So this is where I can say a by-val parameter is almost like a local variable. When you invoke the subroutine, you allocate for it. Okay, it's also allocated on a per invocation basis. So when we are invoking the subroutine, we'll allocate column D for my by-val parameter x as if it is just a local variable. But there's one little extra thing that we have to do as well. Is with a local variable, it starts with an unknown value. Nobody's going to tell me what value a local variable is going to start with. But with a parameter that is passed by value, the invoke statement is going to tell me what it is supposed to start with. So in this case, column D actually has an initial value of 5 because the invoke statement is saying so. It's saying, okay, x should start with a value of 5. And this is the difference. This is the actual difference between a by-val parameter and a local variable as far as this class is concerned. Then on line 3, I have no problem now, because if you look at the right-hand side, we refer to global variable y, which has a value of 14. We refer to the by-val parameter, which acts pretty much like a local variable, has a value of 5. 14 plus 5 is 19, and then we use it to update the left-hand side, which is y. And so now y, which is on column B, ends up with a value of 19. We go to line 4. Just like a local variable, when you're at the end of an invocation, you also have to deallocate your by value parameters. So once we take note that we continue execution at post, we deallocate both column C and column D as if x is just a local variable. And we're done. Okay? So the concept of a local, a by-val parameter is really just kind of like a local variable, except it starts with a particular value, and that value is specified by the invoke statement, not the subroutine itself. Yep.
And with the by-val statement or by-val command, the invocation has to have a set value for x.
Yes, the invoke statement has to specify the initial value of the parameter. Yeah. Because without the int tray, basically you're looking at an int tray, and it has to have something when the subroutine starts execution.
How would you specify multiple by-val statements? Do you just use a comma?
No, you just use different lines. In this class, because it's just a pseudocode, in this case. So if you want to say by-val x comma z, that's okay. I can understand that both x and z are local variables. No problem. I can definitely do that. And we have 3 more minutes. I'm going to give you a second example of something that we already have seen many, many times, but some of you may have forgotten about that one. So it's a good time to refresh. Find max 2. Yeah, that one. So we'll say by val xy because I want to find the maximum of x and y. And at this point, we still don't have a way to return a value. In other words, we don't have a way to report back and say, hey, the maximum is. Okay, so that one we still have to use a global variable for that purpose. So, but the rest is something that we have seen many, many times. If x is greater than y, then z gets the value of x, else z gets the value of y, and if, and define sub. And then outside of the subroutine, we'll just go ahead and say invoke find max 2. And now we have to specify the initial value of x and y. So we can say 4 goes to x, and 11 specifies y. And that becomes my new program. And we'll go ahead and trace it. Oh, we need line numbers. All right. So we have comments, line number, and then we have a variable z, but that's the only global variable in this case because both x and y are by value parameters. And that's my precondition. Start execution on line 9, allocate for return line number, allocate for each by value parameter, which in this case we have x and y. X gets an initial value of 4, y gets an initial value of 11. Return line number is post. Then we continue execution in the subroutine on line 3. X is greater than y is false. We go to the else part, which is starting on line 6. Z gets the value of y, which is 11. And then we get to line 8, the end of the subroutine. We take note that we have to continue execution at post. And then we have no use of these 3 columns anymore. Deallocate those. And we follow our instruction earlier to continue execution at post, which means we're all done. Yep. And we still have 45 seconds left. Alrighty, I'll see you guys on Tuesday. And for those of you who like to think about stuff before the next class, change factorial to make use of by val parameters. See whether you can do it. All right.
I totally over and I had a cosplay panel.